Okay, so looking at the lateral and surface area of a pyramid. So in this one, if you look at what we're given, we have a square for the base, so all of these sides are going to be 12 here. We have that the height of the pyramid is 6 meters. Now, keep in mind, this is important. This is not a slant height. This is the height. It's going from the vertex, it's perpendicular to the base. So we're going to end up needing the slant height for the equations on this problem. So what we end up doing is you're going to kind of separate a little right triangle. Now the right triangle that I'm pulling out here, it's basically made from taking that point in the middle there, and I'm kind of extending that to the middle of the side of the base. And then I got my little hypotenuse that I'm drawing at a weird angle. It doesn't look too great there. And then we have that original height. So obviously not the best art right there, but that's why I took it out to look at. So we have the slant height, we have the height of 6 meters, and then remember, if we're going from the center of the square to the edge, and the square has lengths of 12 for each side, we're going 6 meters to get from the center of that square to the midpoint of that side. So that's why we have 6 meters on that bottom side there. Now, like I said, it's a right triangle, so we're going to be able to use the Pythagorean theorem. If you recognize that it's an isosceles right triangle, or a 45, 45, 90, you could actually go ahead and use that too and be like, oh, okay, if I have 6 here, 6 here, it's going to be 6 root 2 here. So that's one way to do it, if you remember the special right triangle as well. But either way, you can go Pythagorean theorem. So we got 6 squared plus 6 squared equals the slant height squared. So we get 36 plus 36 equals L squared, and we're going to take the square root of both sides. When we have 72 equals L squared, we want to know what L is. So the square root of 72, you can do a little factor tree there to simplify it. So let me just do that off to the side. So we have 9 and 8. Those are two numbers that come to mind. With 9, we have 3 and 3. With 8, we have 4 and 2. And then we can split that 4 up into 2. So we have a pair of 3s. That means a 3 is coming out. We have a pair of 2s. That means a 2 is coming out. And then we have that 2 by itself, so it's staying put. So we end up with 2 times 3 root 2, which is 6 root 2. So that's where our slant height came from. All right, so we have a slant height of 6 root 2 meters. If you wanted to go decimal, it would be 8.42. Let's say you didn't end up, maybe you didn't remember how to simplify the radical. You could just go straight to taking the square root of 72 on your calculator and get 8.42 meters there. All right, so a little bit of extra work at the beginning, but let's remember I'm just a little long-winded, and we just did the Pythagorean theorem. All right, so the lateral area, we're going 1/2 the perimeter times the slant height. Now, again, the perimeter here is basically saving us the time of doing, each individual triangle here, taking the lateral area of, or taking the area of 4 different triangles and then adding them together to be the lateral area. By doing the perimeter, remember, the area of a triangle is 1/2 base times height. Instead of having 4 individual bases that we do that with, we're just adding them together because they're all getting multiplied by the same slant height anyways. So that's where that equation comes from. So we have the perimeter, if it's a square and we have a side length of 12, 4 times 12, or adding 12 together 4 times is going to get you 48 meters. So we have 1/2 times the perimeter of 48 times the slant height we found of 6 root 2. Now, keeping it in radical form, we get that the lateral area is 144 root 2 meters squared. If you happen to go decimal and round to the nearest hundredth, you're going to have 203.65 meters squared. So that would just be doing, the square root of 2 times 144 on the calculator. Now, the surface area is going to be the lateral area plus the area of a base. Now, notice that it is not 2 times the area of the base like with prisms and cylinders. And the reason for that, pyramids only have 1 base. That little point there, that vertex, it has no area. It's already been counted when we talk about the lateral area. So we're just doing the area of 1 base. Now, if we're talking about a square, that is side squared, so we're going to do 12 squared. So we have an area of the base is going to be 144 meters squared. So our final surface area is going to be 144 root 2 plus 144, and that surface area should be 347.65 meters squared.